Hello year 10s. Before Christmas holidays we did Newton's first law. Now we are moving on to Newton's second law. The key words we will be using in this lesson is force, Newton, mass, kilogram and acceleration. Okay, now before we move on to Newton's second law, we did Newton's first law quite a while ago, isn't it? So we have to recap that. Let's see how much you can remember from Newton's first law. So you will see a few questions popping up, and then pause the video, give yourself around maximum 3 minutes, and then do these questions. So the questions are these three ones that you can see on the board now. So now I want you to pause the video, read through the questions and do them. Okay, now I'm assuming you have paused for 3 minutes and then you're coming back to check. So what is the resultant force when a car has a thrust of this much newtons and a friction? Thrust is what allows a car to go forward. So this is our forward force. Friction is something that always opposes the motion. So there is a forward force of 3,500 Newton and a backward force of 3,200 Newtons. So what will be the resultant force? You have two forces acting in opposite directions. So the resultant force should be 3,500 minus 3,200, which is 300 Newtons. Okay, is that what you got? Okay, moving on to the second one. Draw a free body diagram of a person skydiving with a weight of 700 Newton and a resultant force of 0 Newton. So if the person is having a resultant force of 0 Newton, what should be the other force acting on the person? So if this is the person, the weight acting on the person is 700 Newtons. He is skydiving. So which should be the other force acting on him? He is skydiving. So he's moving through air. So which should be the other force acting on him? Yes, air resistance. But since the resultant force is 0, it tells us that the other force acting on the person is having the same magnitude but a different direction. So the free body force diagram should have, you should label the forces, don't forget that, a weight of 700 Newtons and an air resistance of 700 Newtons upwards. Now, the last one, what is the resultant force of a car? So we have a car with a thrust, so that is our forward force, 2,700 Newtons. A braking force. So braking force should act in the backward direction, isn't it? So 2,400 Newtons there. Friction also acts in the opposite direction, 6,000 Newton. So the total force towards the left is 3,000 Newtons. And the total force towards the front is 2,700 Newtons. So the resultant force should be 300 Newtons. 3,000 minus 2,700, and it should be towards the left. Okay, so these should have been your answers. Now, moving on to Newton's second law, you can see two pictures, two cars, two different type of cars on the board there. One is a Lamborghini and the other one is a Ford. So the question is, I will show you a table very soon. You have to fill that table. So we are going to discuss the features of each car, which makes it really good or bad for speeding up quickly. So Lamborghini, you have known that is a sports car. It goes really fast. What do you think makes it good for that? And compare it with the Ford and then think about what it is. And I'm sure, pretty much sure, the first thing that comes to your mind would be something to do with its shape. What is it? It is more. What can you say about the Lamborghini? It is more streamlined. But the Ford Galaxy is not streamlined. It is too big, isn't it? Anything else you can think about which makes Lamborghini take that speed that it gets. What do you think about the engine size, the power of the engine, the size of the engine? Which one will be having a more powerful engine or a bigger size engine? The one that can take more speed, isn't it? So definitely Lamborghini is going to have a bigger, more powerful engine. And what do you think about the overall mass of the car? Which one would be lighter? Is it going to be the Lamborghini or the Ford Galaxy, which is going to be lighter? In that case, you can just think about, say you have a truck with you and you have a cycle with you. You're applying the same force to the truck and to the cycle. Which one is going to go faster? Obviously, the cycle is going to go faster. Did anyone say the truck is going to go faster? No, right? Okay, the cycle is going to go faster. So if you want something to move faster, less the mass it has, the more faster it will be able to move. So considering that, the two key things we were looking for is the engine size and the mass of the car. So next we are going to see why would having a bigger engine size be an advantage, and why would having less mass again be an advantage for a greater speed or for accelerating the car. So the larger the engine, larger will be the, what will be there? What will be that coming in that force? There is a word bank, I'll give you that later. More the engine, what does the engine do? The engine gives the car the power, isn't it? So more the engine means larger will be the power or the force. Okay, and if the force is larger, what can you say about its acceleration? It's going to accelerate more. So like I said before, I gave you the example of a truck and a cycle. Say, but then now think, I have two cycles with me. One I'm giving 10 Newton force and the other one I'm giving 10,000 Newton force. Which one is going to move faster? The more the force I give, the one which I gave more the force, isn't it? So that is how force and acceleration is related. The more the force you give, more will be the acceleration. And smaller the mass, again, this is where the truck and the cycle comes. Smaller the mass, it is easier for us to accelerate it when you apply the same force. For example, just imagine you saw a baby. You lifted the baby in your hands, cuddled the baby, very soft, cuddly baby, good. Then, if you, with the same force that you applied to lift the baby, see you're going and trying to lift someone from WWE, what would happen? Nothing would happen, isn't it? So smaller the mass, it is easier for you to accelerate. So that's why I said I'll give you the word bank later on. So larger the engine, larger the force, and larger the force, acceleration will be greater. Smaller the mass, the easier for it to accelerate. Okay, can you see how force and acceleration is related to each other and how mass and acceleration is related? More the force, more the acceleration. Smaller the mass, more the acceleration. Is that clear, all of you? Now, what we said in the previous slide can be summarized as our Newton's second law, or that itself is basically our Newton's second law. So the law states that the acceleration produced in an object depends on two things. What are the two things we said in the previous slide? More the force, more the acceleration. More the mass, less the acceleration. So acceleration depends on force and mass. So the acceleration produced in an object results on the resultant force, if we are more correct, and the mass of the object. So force, mass, and acceleration are dependent on each other. And that is our Newton's second law. So how they depend on each other can be combined into a single equation which states F is equal to ma, where F is the resultant force. It is measured in newtons. Mass is always measured in kilograms. And by now you're very familiar with the unit of acceleration also, meter per second square. Okay, so this is Newton's second law. Now, before we go on and try some mathematical questions, let's define Newton. So they can always ask you to define 1 Newton. So when we look at the equation for force that we have studied just from Newton's second law now, we know that F is equal to ma. So see, I'm going to consider an object whose mass is 1 kilogram. I applied some force because of which it got an acceleration of 1 meter per second square. So this is our situation. I have an object whose mass is 1 kilogram and I applied a force because of which it got an acceleration of 1 meter per second square. So we can easily find out what that force is. So mass is 1, acceleration is 1, and I end up getting 1 Newton. So what is 1 Newton? 1 Newton is that force which is producing an acceleration of 1 meter per second square in an object of mass 1 kilogram. So that is how we define 1 Newton. The force that produces an acceleration of 1 meter per second square in an object of mass 1 kilogram. Okay, keep this in mind in case they ask you in the exams. Okay, so now we will move on to do some mathematical questions connected with F is equal to ma. Okay, so let's look at the first question. What is the acceleration of a car which has a force of 100 newtons? So F is given to you and a mass of 10 kilograms. So force and mass is given. Everything is in the right units. So we just now studied that F is equal to ma. So 100 is equal to 10 times A, which means A is equal to 100 divided by 10. So that should be 10 meter per second square. Okay, I can't write that second square because it goes outside the PowerPoint. So don't forget, the answer is acceleration is 10 meter per second square. Okay, is that okay, all of you? It's a simple one. Then, if the force is now increased, what happens to the acceleration? We studied in Newton's second law. When force increases, what happens to the acceleration? The force is increased. So the acceleration should also increase. Then, if the force is now 200 newtons, what is the acceleration? Accidentally, I just pressed on my laptop, so the next question has popped up. Ignore that. Listen, concentrate on the second question. So the force, if the force is increased, what happens to the acceleration? The acceleration will also increase. Then the force is now 200 newtons. What is the acceleration? If you want, it is the same object. So you can do, so the mass is again 10 kilograms. You can do all the calculations again. Otherwise, an easier option is initially force was 100 newtons in the first question. Now the force has become 200 newtons, which means the force has doubled. Whenever the force doubles, so if the force has doubled, then since it is the same mass, acceleration will also double. So initially, if you had 10 as the acceleration, now the acceleration will be 20 meter per second square. Okay. And then if the mass of the car is decreased, what will happen to the acceleration? So the mass of the car has decreased. What will happen to the acceleration? Smaller the mass. Think about the truck and the cycle, smaller the mass, more will be the acceleration. So the acceleration is going to increase. The mass is now 5 kilograms. So let's think that it is now related to question 2, where the mass was 10 kilograms. So if the mass was 10 kilograms, it has now become 5 kilograms, which means the mass has become half. If the mass has become half, whatever happens to the mass, the opposite happens to the acceleration. So if the mass has gone down by a half, then the acceleration should go up by a half. So acceleration was 20, you times it by 2, so the new acceleration is 40 meters per second square. So do you get that? Whatever happens to the force, the same thing happens to the acceleration, provided the mass is not changing. So if force doubles, acceleration doubles. If force becomes half, acceleration becomes half. If force is multiplied by 100, acceleration gets multiplied by 100. Then whatever happens to mass and acceleration are inversely proportional. So if mass doubles, acceleration becomes half. If mass triples, acceleration becomes 1/3. If mass goes down by a factor of 6, acceleration gets multiplied by a factor of 6. Okay, so this is how you do Newton's second law. Okay, so with that, actually, we come to the end of Newton's second law. So this last slide that you have there is a simple activity that you can do in maybe 5 minutes. So that will sum up everything that we have done in this lesson so far. Once you have done this, I have given you a sheet along with this PowerPoint. I want you to do the sheet, and the last 20 minutes we will be discussing that sheet in the class. Okay, so if you have any doubts regarding Newton's second law, you can ask me that time. Okay, that's all from Newton's second law. See you soon. Bye-bye.